Welcome to lesson 9, the product and quotient rules. So we are going to go ahead and learn the two rules that we need to take the derivatives of a product and a quotient. And we'll start by looking at the product rule. So what we're going to do is just a really quick example that shows us why we need the product rule. So we're going to look at f of x is x squared and g of x is x. So on this left side, we're going to start by finding the product of these two functions. So we're going to multiply f and g, which would be x squared times x, so x cubed. And then we're going to take the derivative. So the derivative of this product. So the derivative with respect to x of f of g, f times g, would be, well, just use our power rule, 3x squared. So this is the derivative of the product function. Now on the other side, we're going to find the derivative of each function first. So we're going to do f prime and g prime. F prime will be 2x and g prime will just be 1. And then we're going to multiply those two derivatives together. So f prime times g prime, which will just be 2x. So on the left side, we have the derivative of the product, and on the right side, we have the product of the two derivatives. And you can see that these two things are clearly not the same. So it does not work if we are trying, and what we are trying to do is find the derivative of a product function. We cannot just take the derivatives of the two individual functions and multiply them together. Okay. So instead, we're going to use the product rule. And it looks a little funky, but it's generally pretty straightforward. We can get through the notation. So if f and g are differentiable, we can take the derivatives of them. Then its product is also differentiable, and the derivative of the product is equal to this string of things. So let's look at what we have. I'm going to call f the first function and g the second function in our product. So the derivative of the product is just the plain old first function times the derivative of the second one plus the derivative of the first function times just the second function. Okay. So that was kind of what I was going to write down here in other words so that you just have a way to kind of decipher that notation. So the derivative of the product of two functions is the first function, I'm just going to use func as a shorthand for function, times the derivative of the second function plus the second function times the derivative of the first. And it doesn't matter what order you do that in. I mean, this is a plus, right? So you could swap the order of the things that you're adding because it doesn't matter. So that's our product rule. And then one last thing I just want to put on top here is to make sure that you always simplify your results. So I mentioned a little bit in lesson 8, some of the rules for simplifying. We don't want fractions within fractions. We don't want negative exponents. We don't want things that could be combined like terms. You want to simplify your answer reasonably, okay? So let's look at an example here. The first one, we're going to find the derivative of e to the x times x squared. So we have function number 1 and function number 2. So the product rule tells us that that derivative will be function number 1 times the derivative of function number 2 plus the derivative of function 1, which is still just e to the x, times function 2. So it's just a straightforward application of that product rule. There's really nothing to combine here, but we usually write like e to the x times 2x as 2x e to the x and x squared e to the x. I mean, I suppose you could factor out an e to the x, but it doesn't really get you very far. Okay. So we're going to do this second one by using the product rule, and then we're also going to actually do the product and make sure that those two things are equivalent once we take the derivative. So I'll just put a line here. And the first thing we're going to do over here is first we're going to multiply out h of x. So I'm going to rewrite. Remember, this is what we kind of had to do in lesson 8. We didn't have the product rule. So if we were trying to find the derivative of this, we needed to rewrite the square root and then distribute it so that now we could take a derivative term by term. And, we talked about simplifying that as well. So I would have 1 over 2 root x plus 3 root x over 2. So that's the first way. Now let's try using the product rule. So my first function will be the square root of x, and my second function will be 1 plus x. So h prime will equal, all right, the first function, which I'm going to write it in exponent form because it's going to just be easier to do the simplifying. So the first function times the derivative of the second function. Well, the derivative of 1 plus x is just 1, plus the second function times the derivative of the first function. Now we definitely have a couple things to do to simplify here. I'm going to need to distribute this 1/2 x to the negative 1/2 first. So I'll have 1/2 x to the negative 1/2 plus 1/2 x, let's see, x times x to the negative 1/2. I add those exponents. And then I have some like terms. I have 1x to the 1/2 here plus 1/2 x to the 1/2 there. So that would be 3/2 x to the 1/2 plus 1/2 x to the negative 1/2. And you might note right here that those two things are equivalent. So I could, rewrite this one back in the same form that I wrote the other one, but you could see it at that step before that these two things are in fact equal. So the product rule is the only way to get the correct derivative of a product. Okay. And then I also just want to follow through on something we had talked about also in lesson 8, which remember I had said in lesson 8, once you learn the product rule, you may not always want to use it. I mean, which of these two sides did you find easier, less cumbersome with the algebra? Personally, I actually think that this was a pretty quick multiplication and then boom, boom, one-step derivative. Here, I had to remember the product rule. Then I had to do some distributing, which required some algebra. Then some combining, which required a little more algebra. It wasn't deep thinking, don't get me wrong. But this seemed to just take a little bit more work. So the product rule is there. If you go back to the first one, I don't have an option here. I can't actually multiply e to the x times x squared. So when I want to take its derivative, I have to use the product rule. But when we look at number 2, I can do the simplification. And in this case, maybe it was a little bit easier, but for more complicated ones, it's probably even easier to do this way as opposed to apply the product rule. The product rule starts to get a little bit more algebraically involved. Okay, so this is the first time I'm going to say what I'm going to probably end up saying a lot, which is you really want to think about the smartest way to go about something. And so in this conclusion here, I'm going to say, if possible, simplify your function algebraically by multiplying it out before taking a derivative. You will see in the worksheet for this lesson, there are a number of problems that I have given you where it's asking you, can you simplify this? And then if you can, do it. And then it asks you, do you still need the product rule or do you still need the quotient rule? Because the same thing goes for the quotient rule. And if you simplify it, you multiply it out, you may not need the product rule anymore. And I will also say, spoiler alert, that I definitely have been known to put on an assessment a problem where the product rule is kind of gross, but if you had just multiplied it out first, or maybe it's the quotient rule, if you had just multiplied it out first, the problem is infinitely easier. So think smarter, not harder. Do I really need the product rule?